All right, I think with everyone here and it now being 3:05, which is official MIT starting time. Hello everyone. Thank you all for coming. It is a pleasure to have you all here. Welcome to Where is the Line Drawn? Today we'll be having a fun and thought-provoking discussion on the intersection between neurotechnology and ethical issues. More specifically, we'll be raising and answering questions surrounding the idea of human augmentation and cognitive enhancement. What is it? How is it being done? Who has access to it? Who's in charge of it? And of course, where do we draw the line when it comes to enhancing the human brain? My name is Malik George, and I'll be hosting today's talk. A little bit about me. I'm a rising junior at MIT studying bioengineering and African diaspora studies. And I've been doing research in the Synthetic Neurobiology Group since January with PhD student Shannon Johnson and Professor Ed Boyden. Now, before we begin, I'd like to go over the layout for today's talk. We are going to start with the panelists discussing the state of enhancement and sorry about that. We're going to start with the panelists discussing the state of enhancement-oriented neurotechnology and the ethical questions arising from their use. Afterwards, we will open up the floor to you all to ask your own questions about the topic to the panelists. To submit a question, please use the Slido link, which is displayed as well as posted in the Zoom chat window. I'll give you all a brief moment to join the Slido before we start. The Slido is helpful because not only can you ask your questions that we can see in live time, but you can also upvote other people's questions. This way, we can make sure to ask the most common questions first and then ask other questions as time permits. Please note that Professor Boyden, Shannon, or myself may also respond to some of the questions in the Zoom chat, so be on the lookout for those. With all that being said, let's introduce our panelists for this afternoon. First, Dr. John Krakauer is currently the John C. Malone Professor of Neurology, Neuroscience, and Physical Medicine and Rehabilitation, and Director of the Brain, Learning, Animation, and Movement Lab at the Johns Hopkins University School of Medicine. His areas of research include experimental and computational studies of motor control and motor learning, prediction of motor recovery after stroke, and new neural rehabilitation approaches for patients after stroke. He received his bachelor's and master's degree from Cambridge University and his medical degree from Columbia University of College of Physicians and Surgeons, where he was elected to Alpha Omega Alpha Medical Honor Society. Next, Roland Nadler is a PhD student at the University of British Columbia's Peter A. Allard School of Law. He previously taught courses including Law and Neuroscience at the University of Ottawa and served as a fellow with the Center for Law and the Biosciences at Stanford Law School, where he also earned his JD. Roland gratefully acknowledges the honor of being supported by his studies by a Vanier Canada graduate scholarship, as well as the privilege of living and learning on the unceded traditional territory of the Musqueam people. Thirdly, Anna Wexler is an assistant professor in the Department of Medical Ethics and Health Policy at the Perelman School of Medicine at the University of Pennsylvania. She received a dual Bachelor of Science degree from MIT in Brain and Cognitive Science and the Humanities and Science with a focus in writing and neuroscience. She received her PhD from MIT in the History, Anthropology, Science, Technology, and Society, or HASS program, where her dissertation centered on the DIY brain stimulation movement. She is the recipient of a 2018 NIH Director's Early Independence Award. Please welcome our three panelists for today. Gosh, always confusing on how to clap during Zoom panels, but
Zoom clapping.
Great. Now, moving into the discussion portion, panelists, feel free to answer any question that you wish, and we're going to keep this open-ended. For our first question, what neurological tools and devices are commonly used to modify and improve brain function?
Well, I guess, should I have a go at answering that, Malik, or do you have someone in mind?
Sure, yeah, you can answer.
Well, I think for the sake of the conversation not being huge, I think you're talking more about enhancement in healthy people rather than fixing or repairing the ill. Usually we don't talk about enhancement when it comes to the ill, because they're just trying to be returned to normal. So I'm going to assume that we're talking about enhancement. Now, there are various flavors of enhancement, ones that people will know about, like cochlear implants, but even there, that's more for people with a deficit, although that's an open question. When it comes to actual enhancement, what people are interested in is making you better than you would be otherwise, cognitively, motorically. And right now, it's very, very early days, right? The military is always, not always, but pesters me fairly frequently to see ways of making people into super soldiers. And there's an assumption sometimes that what works to help patients can be somehow inverted to make people even better than normal. What are concrete examples? There's a vast industry right now trying to cognitively enhance people with all sorts of brain training. That usually takes the form of software and apps. For the most part, it's all nonsense, but there's still a belief that perhaps one can cognitively enhance the healthy or the healthy aged. There's a lot of work being done on vagal stimulation, even in the healthy, with the idea that this may have an enhancing effect on cognition. Transcranial direct current stimulation, there's even a company that sort of bet on this, that you could do a non-invasive brain stimulation on healthy athletes and healthy soldiers and have effects on skill and cognition. There's the belief even that maybe you can get more invasive and perhaps get away with doing brain stimulation from an invasive standpoint for cognitive enhancement, although that's still a little ways away, but it's something that is what companies like Neuralink and others are kind of talking about. So you can open up the ethical discussion about it, but right now it's very early days whether any of the approaches I've just mentioned are successfully causing enhancement in the healthy. There's more that's been done successfully in the ill, and I'll stop there.
I think that's a great overview. I'll just add one more technology that's being sold to consumers. So this is where I come in is studying the consumer direct to consumer landscape of neurotech. So I've written a paper questioning whether this actually works or not, but there are direct to consumer EEG devices being sold on the market for enhancement. So whether they work or not, I don't think there's a lot of evidence supporting the efficacy of these devices, but they're being sold to consumers. And also neurofeedback in general is offered by some alternative practitioners or providers directly to consumers.
In the spirit of the panels sort of having this central question of where is the line drawn, I think one other thing I would just point us to is the limits and boundaries of this concept of cognitive enhancement. What we talk about when we usually talk about it are the types of things that John and Anna have spoken to, but it's worth not forgetting that there are very common modalities that many of us engage in for cognitive enhancement. Substances like caffeine, certainly. Also, humans naturally enhance each other through the sort of communication and transmission of ideas. These are all enhancements to our cognition, but they're not the ones that we are focusing the special ethical lens on here. And worth too thinking about the fact that cognition is a broad term. It need not just sort of refer to reasoning ability. Certainly for centuries, people have used non-stimulant substances to enhance things like mood and creativity.
And one other thing that I forgot to mention is, there are people working on off-the-shelf video games and showing that off-the-shelf video games, Daphne Bavelli in particular has done work in this area, can have unexpected generalization on psychometric tests, even though that they weren't taught to in the video game. So I would say that's another area that people are interested in, which kind of overlaps a little bit with the brain training industry but the idea that gaming might have an effect on cognition.
Thank you all for your thoughtful responses for that question. Moving in, this is a bit of a three-part question. But so when it comes to using and creating neurotechnology, what regulations and ethical review methods are in place when approving neurotechnology research, and how does that differ from when you're approving neurotechnology for medical or therapeutic use, and finally, how does that differ from when using a piece of neurotechnology for personal enhancement methods?
I could take the first go at this one. I guess in the spirit of trying to focus the discussion, because this is, spend a whole semester talking about these things. I would say that one of the more interesting things from my perspective is the fact that many of these neurotechnology companies that are marketing products directly to consumers are not marketing them for medical uses. They're marketing them for recreational uses or for enhancement uses. So traditionally, when you have a device that let's say you're a company and you want to develop a neurotech product, and let's say you want it to have some sort of medical, you're marketing it for some medical indication, you would traditionally go through FDA and medical device oversight. So FDA would review your product as a medical device. What's interesting about the direct-to-consumer neurotech space, and so there's a set pathway. If you want, we could get into the details. But there are these companies not marketing their devices for medical indications, so marketing them for enhancement or memory improvement, or improving your focus, things like that. And there things get a little tricky, so it's not really clear whether these devices would be considered medical devices under FDA, and there's some disagreement about how the FDA would consider these devices. I think an argument could be made on either side about whether they should be considered medical devices or not. I think it's worth noting that at the moment, FDA has not taken any regulatory enforcement action against the currently available devices that are on the market. And again, this differs for whether a product is, let's say, providing brain stimulation non-invasively versus you're just marketing a brain training game for enhancement, or if you're marketing an EEG recording device, if you have an EEG device that you're marketing for enhancement. The FDA has indicated in one guidance that it may consider a brain stimulation device marketed for enhancement purposes as a medical device. It hasn't been totally clear on that, but it hasn't taken any action. So effectively, FDA has not, the bottom line is FDA has not, may have jurisdiction, but it has not enforced its jurisdiction over these devices. Roland, you can also clarify there.
I was going to add just as a footnote and an emphasis on your point that the FDA hasn't brought an enforcement action around this yet. That would be an important moment, because it would provide an opportunity to fight out in court whether it's actually true that the FDA could exercise regulatory jurisdiction over sort of non-medical uses of these devices. And I can tell you as well that as a matter of sort of administrative law doctrine in the United States, that's a fight that the FDA would be likely to win. Obviously, there are no guarantees in litigation, but the idea that you sort of defer to an agency on what is the scope of its regulatory jurisdiction is pretty well established at the moment in American administrative law. I will not speak out of my depth on the Canadian picture, which, despite being a scholar in Canada, I am not actually as up on as the FDA.
I would just add that this is a moving target. It's very difficult sometimes. I mean, wellness is usually not FDA regulated. But if you make a claim like Lumosity did, for example, that you could, reduce the onset of dementia by 10 years, That's a medical claim in a healthy person. So you can see how suddenly, where do you put, and as you know, it wasn't the FDA, it was the FTC that slapped them with a $50 million fine, which they managed to get down, pleading hardship, to $2 million. But my guess is that this space will be increasingly regulated. I mean, the other thing, as you guys both know, is that software is currently at the FDA considered a device. And as you know, devices are much more leniently treated than are drugs. In other words, as long as you've got some sort of biomarker or you can show safety, you don't actually have to show efficacy for a device, right? So it's a very murky area. But if enhancement remains in the realm of wellness, but wellness begins to make claims about the onset of diseases in the neurospace, then my guess and my hope, I think, is it should be more regulated, and I hope it does go to FDA.
Yeah, just to add, so, you know, even if a product is, like you were saying, John, even if a product is not regulated by FDA, doesn't mean it's unregulated, which is a common misconception that I think many people have, right? So Federal Trade Commission, right, famously took action against Lumosity for the claims that, the advertising claims that Lumosity was making. And it's actually taken action against a number of other software companies that have made brain training claims, and also supplements that make brain enhancement claims. So the FTC has really been the only federal agency in the United States that's really stepped up to regulate these sorts of claims. The only other action that I'm aware of was in 2013. It came at a state level from the California Department of Public Health that took action against a company marketing a home TDCS device and effectively shut them down. But the last thing I you know, I want to say is it's my sense that FDA will, you know, it is a murky space, at least the way things seem to be going now. Like, it's pretty clear that FDA has been aware of these devices, at least the non-invasive brainstem devices, and the direct-to-consumer EEG devices. They don't seem to have taken any action. They've been completely aware of the space. So I'm not confident that they're suddenly going to jump in and take further action, but, you know, it remains to be seen.
Before we move on from this topic, just one more little point to ensure the audience has an even more complete understanding of how the regulation works here is that, as with drugs, you can have devices approved for a specific health claim, but once they are, there's an extent to which then off-label uses become much harder to regulate. So both when it comes to Health Canada and the Food and Drug Administration, they do not regulate the practice of medicine in the sense of you know, what sort of individual physicians are doing. That is left to the states and the provinces, which means that, as I believe is the case in Canada, with Health Canada's approvals for TDCS for I think it's migraine and insomnia, that existence means the existence of that approval means that at that point, an individual practitioner in a particular Canadian province may be able to say, well, in my own physician judgment, I think that we have a good case for using this device for you for another indication. And if there's going to be any regulation of that, it's not going to be from the federal government.
My group, we're actually doing a study right now on off-label clinics that claim to promote TMS in an off-label way, what they're promoting it for. So we're just finishing up that analysis. But what's interesting is that a number of them are actually promoting advertising TMS for cognitive enhancement. Not many, maybe 10% in our sample, something like that. But yeah, just to your point, Roland, that right, once it's approved for a few things, it can, or one thing even, right, the off-label uses can really span the gamut.
I mean, and you know, we've been here before, right? In other words, Viagra was for people with diabetes and neuropathy, and it became just general purpose erectile dysfunction drug. SSRIs were originally intended for axis 1 depression and became mood drugs that are prescribed for people who do not meet criteria for axis 1 depression. So, you know, this slippage is inevitable. I mean, even though in my view, it's for the most part not scientifically sound, even for the primary indication. Once your foot is in the door, like you say, that's it, right? I mean, antidepressants are actually really not very good, right? So, but once they're in, you can spill everywhere.
Before we move off of this topic, just one quick point of clarification. If one of you could explain, I guess, the difference between the FDA and FTC and their regulation abilities.
I'll go for this, though Anna's equally well suited to answer. So the Food and Drug Administration is the U.S. Regulatory federal agency that deals with, as the name suggests, all kinds of regulation of both medicine and food. And so its responsibilities are to, I think the statute says something to the effect of, to regulate whatever is going to sort of be used to change the structure or function of the human body, right? The Federal Trade Commission, on the other hand, is an agency that's tasked with regulating sort of commerce, trade, advertising. And their Canadian equivalents would be Health Canada for the FDA, and then Advertising Standards Canada, I believe it's called, for the FTC. They may not be exact sort of one-to-one overlaps. Different countries will sort of set up their administrative bureaucracies differently.
I would just add that that in practice, it's really interesting. So when the FDA is generally thought of as having and does have more scientific and medical expertise on their staff, and so there's been really interesting questions when the FTC has, gets into the business of judging whether or not a claim is misleading in the realm of brain training. There was one case, what was his name? Aaron. There was one case where there was an app that was being marketed. I think it was for with claims about better eyesight by a cognitive, not a cognitive neuroscience, maybe a cognitive psychologist at UC Irvine. Anyway, there was an issue, right? So they got into, so the FTC then got into the business of judging whether or not the science was reliable and good, whether this researcher had been doing good science or not. And there, I think, actually, many academics disagreed with the FTC's assessment and of whether or not this had been good science, and wrote supporting letters on his behalf. But anyway, it's just interesting to just think about the relative expertise that each of these agencies brings in terms of scientific and medical background.
I mean, I think just, another meta point about what you just said, right, which is at the heart of this conversation, right, is what happens, unfortunately, is that the technological tail wags the conceptual dog, right? So the technology gets out there, and, America in particular is very techno-fetishist, right? Everyone believes that technology is going to solve everything from climate change to cognition. And so the technologies get farmed out long before the hard biology is thought through. And so, brain training, TDCS, TMS, I mean, the science of those techniques is in its infancy, but yet a company can be formed, and I said to Malik, I have some chagrin when it comes to this, because, we published quite an influential study on motor skill learning in healthy people using TDCS, which I'm sure was used partially as justification for the formation of a company. So there is and I'd be interested to hear from the people who know far more than I about the sort of legal side of this, but it just seems that you get a little tiny justification, you generalize horribly, you put the technology out there, and the science lags way behind and perhaps never catches up.
Yeah, I would say that that's often what happens. And then, so if you think about oversight mechanisms, right, FDA, relative to what the FDA has to do, right, FDA is regulating the entirety, of food, drugs, many medical devices that are far more invasive and, could present far more dangers than the ones we're talking about here today, right? So it's not a big agency, has this huge workload, and it's, you know, in practice, right, it can't go about picking off all these little guys, you know, every little company who's going to start a company, every little person who's going to start a company using your paper, let's say, right, to make one of these claims. So I think that's part of the reason why we see, why we see some of these companies taking off. But on the occasion that an agency does decide to make a statement, like it did with FTC, did with Lumosity, right? They take a big action, and they hope that has some sort of chilling effect. Chilling effect's probably the wrong word, but has some downstream repercussions in terms of warnings to other companies. So FTC certainly did that with Lumosity. FDA hasn't done anything like that in the realm of brain stimulation. But thinking about regulation and also separately thinking about enforcement, or related but different concepts, I think is really important.
Great. Thank you for the discussion on regulation and where its current levels are at. For the last question for the discussion portion, a lot of this talk of enhancement was really sparked when a few years back this DIY brain stimulation movement seemed to arise. And so I was wondering if you could give a summary of that movement as well as how it is doing in the present.
I guess I'll take this one since this was a topic of my entire PhD. So the DIY brain stimulation. So it basically arose when people began reading media reports about TDCS and the potential effects TDCS might have on both for enhancement and for clinical indication. So people started first creating their own TDCS devices at home. Then there were direct-to-consumer devices available. The buzz seems to have peaked around 2014, 2015. That's when we saw a lot of really big media articles. This was probably in every major media publication had an article about do-it-yourself TDCS. It hasn't, I would say it hasn't been taken up by the mainstream. It also has not gone away. So I think it's, right now I would call it, I don't know if subculture, that's probably not the right word. That probably makes it seem a bit larger than it is. But I would say there's certainly devotees of it at the moment, but it hasn't become a larger movement, and I haven't seen a lot of buzz about it recently.
Off that, so do you feel like your work on the TDCS at home is just one part of the more broader sort of transhumanist kind of movement, sort of ways to enhance and extend life and banish death? And is it all part of the same subculture psychologically, or is it different?
So I don't have data on this. I do have, I do have a lot of sociological data on the community. My hunch would be to say it's related, but not the same. I would say these are people who want to, it really splits. So these are people, half of them are doing it to enhance about half are doing it to enhance cognition. I would say the other half are doing it for treatment. So these are patients who are frustrated that, their antidepressants haven't worked. And so they've been reading about its use for depression. But amongst the enhancers, which is I think what you're more interested or getting at, I would say it's more about optimization and quantified self and productivity rather than necessarily transhumanism, although those aren't totally different, separate things, but there's some nuanced difference there.
Thank you.
So this is also largely data-free or anecdote-fueled sociological speculation, but I would say that to the extent that the DIY brain stimulation movement has persisted, it seems to me to have done so despite what I think is quite a drop off in the sort of fervor of kind of transhumanist strains of thought. The general impression that I get of the state of the discourse in the world is that it was much easier in 2010 to have this kind of like soteriological belief about technology that that was truly just going to sort of usher in utopia, and that the only thing that was holding us back was our own sort of moral cowardice in the face of being better, right? all that was a lot easier to believe in 2010 than it seems to me in 2020. Obviously, I'm speaking over a wide array of sort of beliefs about technology and society there. But
I would
definitely
agree that, as a practicing physician myself as well, that what COVID-19 definitely showed was the revenge of the analog, right, versus the digital. I mean, Silicon Valley, they're essentially useless, minus giving us some, Netflix and Zoom, right, if it was them. But in terms of what actually matters, it's nurses and doctors and people working in the street. And we certainly haven't been rescued by digital technology. So I would agree that perhaps you're right, that was already trending, but the uselessness of it has certainly been shown now, right? So maybe the optimism correctly is waning.
Although someone has a question I see on the slide thing to transition to the question about Neuralink and Elon Musk. So there is still some folks who remain very optimistic.
All right. Let's move into the Q&A session. So everyone, I believe the link has been posted. Make sure to ask your questions and upvote any questions that you see you find interesting. To start off with, do you think the visibility of the oncoming Neuralink demo on Friday will spur public discussion, perhaps the FDA to make a statement and begin to take action?
I could start with this one. Definitely, it will definitely spur public discussion. Anytime you have Elon Musk on the stage, there's, extensive media coverage, especially if he's making statements about, brain-computer interfaces or, mind control technology, which he's going to do. I can assure you. I don't think it's going to spur the FDA to make a statement. I feel like the FDA usually does not make a statement until or take action until it has to. But it will certainly spur public discussion. I mean, I'm curious to see where they are. Neuralink is not alone, right? So there's been a number of companies that have invested, quite a bit of money in this space, and the initial sentiments or predictions coming out of these companies were for invasive consumer BCIs, essentially. It seems from what I've been hearing and seeing that many of these companies have sort of walked that back a bit and are now actually pursuing the medical route first, which really is, as we sort of talked about in the beginning, right, that makes a difference in terms of regulation, in terms of the marketing, right, how a product will be regulated. So it's, what Elon Musk says and what the company is actually doing and what the scientists are working on, right? There may be subtle distinctions there in terms of the promotion versus actually what's going on. But I mean, I'm curious to see what they're working on, and especially curious to see what marketing avenue and what indications they're planning to use this technology for.
I mean, we've been here before, right, with Neuralink, and I have people I know who have or work at Neuralink, and there are a lot of technical problems that they probably are solving and they have solved well. And I think, to your point, one should distinguish between the hype and the actual work being done. I mean, it's just such a perfect cocktail, right? I mean, people love brain-machine interface, the idea that you're approaching the singularity together as a hybrid intelligence. I mean, it's all just so exciting and deeply tiresome simultaneously, right? And of course, some of the technical milestones that they will cross will probably be very interesting to scientists who can actually appreciate how one can get better at decoding, etc. But in terms of, what it's going to do outside of the medical space, it's vastly overblown. I'm willing to be proven wrong when we hear what they have. But, I mean, Elon Musk, as we all know, is somebody who believes that AI is much closer, to artificial general intelligence than I believe. So once you believe that, then you can sort of swallow everything else. But I think it's going to be a mixture of real science and complete hype.
Just to add one other footnote on this concept of hype, right? I think it's worth noting that there can be an effect of sort of a regulatory agency or other sort of government action almost creating the kind of response that it envisions, right? So if something like a demo of Neuralink were to spur the FDA to action, right? I think it would have this sort of signaling effect, like, oh, this is prime time, right? And that ties in too to the question of the overall regulatory framework for cognitive enhancement, whether through drugs or devices. Is that I've sometimes seen it asked, like, should we have a specialized agency or task force that sort of works specifically to address the regulatory gaps? And you might worry that that creates something of an if you build it, they will come effect, right? That you're sort of creating this space as a conceptual space through the way that your regulatory taxonomy carves up the world, right? That may be something that, agencies and authorities wish to refrain from doing.
Yeah, a point I was going to make earlier also is, yes, we can say that, there was a study done, I can't remember where it was, maybe one of you know it, which was trying to find out where the hype came from in releases about scientific discoveries. And if I remember the results correctly, it was very depressing that the scientists themselves were somewhat responsible for the exaggeration of the implications of the results, not the press agencies or the PR units of the universities. And so, when it comes to things like TDCS and TMS, it's not just DIY people at home over-interpreting the results. It's unfortunately an enormous amount of bad science continues to get done because we all want to believe that there can be quick technological cures to slow illnesses, right? We want to be fast and shallow when we really should be slow and deep. So everyone is to blame. And I think in this case, we just need to have people who are intelligent commentators who can distinguish the real advances. So for example, if there is a better way to reroute commands from motor cortex to below a spinal cord injury, that's fantastic. And there are all sorts of technical challenges that companies like Neuralink may well solve along with federally funded research. But that's a huge difference from saying that we're somehow going to fuse with the computer and become super intelligent, right? I mean, I wish there were a way to be able to have these conversations separately rather than having them always sort of wrapped up in a way that somebody else then has to disentangle them.
I will say also that ethicists, to criticize my own field, ethicists are also responsible for a lot of the hype, right? So I think it's created at every stage of the process, right? It's just scientists might have something at the end of their paper, right? I mean, it's like traditionally in the conclusion, or right, this may in the future do X and Y, right? Then that's taken by ethicists and the media, and then it just gets into this like huge hype cycle. I actually wrote a piece criticizing the hype specifically in the direct-to-consumer neurotechnology space last year called Separating Neuroscience from Neurohype, or Neuroethics from Neurohype, or something like that. So
I'd say too that even where ethicists sort of take themselves to be resisting the hype or not buying in fully to it, the way that we do our ethical reasoning about cognitive enhancement can itself kind of subtly give into things we want to believe. And my pet example of this is the way that the ethics discourse around enhancement always wants to assume away safety as this issue, right? That we're always thinking in terms of, okay, but what if we could really show that, long-term and across a broad array of populations, this intervention is safe? And yes, there is some ethically interesting reasoning on the other side of that, but that assumption is so dominant in the ethical reasoning about cognitive enhancement, it really distracts from the fact that that is, for the foreseeable future, going to remain the front and center ethical issue. And because we all want to believe that a safe intervention, perfectly safe intervention, exists with no downsides and no side effects, right? There's a way in which we can warp our thinking around that we should be careful to resist, right? Even if it's not actively boosting hype.
I completely agree with you. I think, I see it sort of as a triad. There's how close to our worst fears or greatest optimism is the science, right? Second, is this potentially dangerous even if it could live up to its positive effects? And third, is it ethical to enhance even if it was 100% safe? And what I find is that people tend to collapse one or two of those things. In other words, is it scientifically true? Is it safe? And even if it were safe, should we be doing it? And I find that that it's rare in any given individual for those three pieces to be maturely discussed.
Yeah.
Sorry, but not to cut off this great discussion, but I would like to move to another question, as just for the sake of time. So sorry to cut this off, but a question that's quickly risen to the top of the Slido. Is there a concern that augmenting one thing might impair another thing? Example being, he recalls a discussion whether boosting attention might suppress creativity.
Look, there's been this, I'm going to try and answer this very quickly by saying that, all of what we're talking about rests on the notion of neuroplasticity. And my feeling is, and I don't think I can go into it today, is people have a woeful misunderstanding about what neuroplasticity is. It's greatly overrated in terms of sort of the pluripotential of the brain to rewire, reorganize. Most of it is actually wrong. And so inside that notion then comes the idea of a zero-sum game, that if you expand the amount of real estate available for task A, you're going to have to shrink the amount of real estate for task B, right? Actually, it's been very difficult to prove such a thing. And so if one is going to go down that road to discuss it, one would actually have to go back and really re-examine, in my view, what we mean by neuroplasticity and whether we should think in terms of a zero-sum game or not. And not that I'm saying that I have the answer to that. I mean, I have opinions, obviously, surprise, surprise. But that's what underlies that question. And I just don't think we know or have the time to sort of fully unpack it. But again, that's just another version of the side effect, right? You do one thing. And in medicine, by the way, the last thing I'll say is, amongst doctors, if a medicine doesn't have a side effect, it probably doesn't have a positive effect either.
I just put in the chat one paper I know of that looked at something like this with regard to TDCS. I will say that, and there's more, scientific, everyone on this call is probably, a scientist, or most people are scientists, and I'm trained in science, but I don't consider myself necessarily to be a scientist, but it is a hard question to answer, right? So you have to define what you're, right, like what trade-off are you looking at? You have to know what you're looking for, what, when you're doing the study. And so you could say, oh, I'm gonna, do TDCS, and then, I'm gonna measure their performance on this specific task. Well, why are you choosing this specific task versus another task? And the other general point, right, is there could be all sorts of trade-offs even for drugs that we commonly use, right? So it could be that, and it probably is the case, that maybe antidepressants, right, have certain cognitive trade-offs or side effects. And we don't typically go around, measuring those. FDA doesn't require that we measure subtle cognitive outcomes if you take commonly, take sets of common drugs. So this is not necessarily a thing that is commonly measured, although, of course, right, that's for medical indication. We could say it's a different equation when it comes to enhancement, but it's just a difficult thing to actually design a good experiment for.
The idea about creativity, in other words, we're so far away from having a science of creativity, or let alone some kind of metric that would be useful in a time frame short enough to be able to answer that kind of question. I mean, you could say, let's do TDCS and see if you write the great American novel 5 years later. How would you actually prove that your creativity had been impaired? I mean, it's just almost, it's very similar to trying to see whether video games cause violence, right? Or whether, you know, cell phone usage is bad for you. To, in fact, do a study that could really answer that sort of question, it's almost impossible.
Thank you for that. I think we might have time for one more question. So next up is, given the current manipulations of an absence of high-level cognitive biomarkers, don't you think the best avenue for neural enhancement remains pharmacology?
Definitely going to answer that first. I would say absolutely not. I would say that if one thing we've learned from the woeful track record, for example, of new psychiatric medicines, the constant failure of the Alzheimer's trials, I would say that the one good thing about what we're talking about here, which is sort of top-down approaches, more holistic cognitive approaches, that the reductionist pharmacological approach when it comes to things like cognition just don't work. And I'll just give you a thought experiment, which I think helps my students. If I were to say to you, Malik, take this pill, and tomorrow you'll win Wimbledon, right? You would know intuitively that that's utter nonsense, right? That you're never going to have a pill that makes you a concert level violinist 24 hours after swallowing it. But somehow, as soon as you get to neurological illness, that instinctive logic of the nonsense of it goes away. You suddenly think that there will be a pill that can reverse cognitive disorders or enhance cognition. It's going to be, in my view, behavioral interventions, slow interventions, multimodal interventions like exercise. And yes, maybe there'll be a modulating effect of drugs on top of that. But I would say that despite my skepticism throughout this panel, reductionist pharmacological approaches have really been extremely disappointing.
Just even to sharpen the point about winning Wimbledon, right? While it may be the case that very few individuals in the history of the world have won Wimbledon, whereas a great number of individuals have been in a profoundly depressed state and ultimately made their way back to a more balanced state of mental health, those are both extremely challenging and subtle tasks to undertake. And I think there's not much better reason to think that you could have a pill that makes you a Wimbledon winner than a pill that, just in the same straightforward way makes you capable of overcoming depression, right?
Precisely.
Yeah. I will just add that it also depends on how you define neuroenhancement. So coming back to what Roland was saying, right? If you just talk about it as general enhancement, like drinking cups of coffee or doing things we might do in everyday life, or even, getting SAT tutoring to do better on your SATs, right? So you could think about enhancement as being something that's, already inequitably distributed in our society. So I forget what the original question is, but, being born into a certain race or class or having a certain income might also affect your ability to cognitively or to be exposed to or have access to certain cognitive enhancements, depending on where we want to draw the line of what.
And I certainly harbor the fear that that if we had a sort of available and effective cognitive enhancer, that it might sort of be pressed into service in curbing sort of the surface manifestations of those inequalities, while we let the deeper causes continue to fester.
Right, and I think it gets to the point that you could think of technology in two ways. Do you want technology to be a short, sharp shock like a pill? Or do you want to have technology be something more imaginative and top down that can begin to apply to these broader problems that are far more important when it comes to what leads to depression and stress and anxiety and early death, etc. So I would hope that technology be used the way I'd like to use it, which is as a top-down behavioral intervention that addresses more multimodal factors, rather than just being, we'll instead of a pill in your mouth, we'll put a chip in your brain, right? And it's that sort of delta function view which I really object to.
Also to the question, as it sort of is looking for what do we think will be the most effective route for neuroenhancement, I will provocatively suggest that actually the most promising route won't involve either pharmacological or sort of direct electrical or any other sort of impingement on the brain, that it will much more likely be AI, right? That is a proliferation of AI assistants that are sort of looped into the individual cognitive tasks that we do probably has a much greater chance of manifesting what we're talking about when we talk about cognitive enhancement anytime soon, right? I mean, you know, I could imagine myself, if I had sort of GPT-3 access and enough free time, sort of building a little, you know, like a script that's sort of trained on a corpus of my own writing to then like be a way of interpersonally reflecting on issues by myself, right? And that certainly talking something out with somebody whose perspective you think is good is a kind of cognitive enhancement, right? Just not one that we.
So is an iPhone, right? If you get lost in the woods one weekend and you have GPS on your iPhone and it tells you what mushroom you can eat without dying, that's had far more effect on enhancing you, and you become somewhat intelligent in a forest, right? That where otherwise you you probably perish within 24 hours. So that's quite remarkable.
I would certainly perish.
So I agree with you entirely. Yeah.
If that's all we want to say on that question, I believe that takes us just about to the end of today's discussion. Let me just put my slide back on. I'd like to thank all the panelists for coming out today. You had a very great discussion. It was great hearing from you. Thank you, Professor Boyden and Shannon, for helping me organize today's panel, as well as working over the summer. I'd also like to give a brief thank you to Joshua Sainz, Peter Reiner, Anthony Zador, and Jonathan Moreno, who I spoke to over the summer about this topic. If you'd like to hear more about this topic, there's some resources have been posted in the link to the Zoom, as well as some books that I took out over the summer, which are shown on the slide: the Routledge Handbook and several neuroethics textbooks, as well as a interesting read, Better Than Well, which is from a critic of neuroethicists, which was a fun read, as well as the Neuroethics Society and the Neuroethics blog for many articles on this topic and others. Thank you all for joining me today, and I hope you continue to question where is the line drawn and continue to have these great neuroethical discussions as you continue your work and studies in the neurological fields. I hope you all have a great rest of your day and rest of your summer. Thank you for coming out.
And thank you, Malik, for going to all this trouble.
Yeah, thank you so much, Malik.
Thank you.
Yeah, thank you so much. I mean, it's very clear this is the beginning of a conversation that's going to keep going on, and it's great to be here at the beginning of lots of new technology. So thank you so much for everybody for organizing and participating.
Thank you.
Awesome.
Bye.
Thanks all. Cheers.
Great. Thank you so much. Have a good afternoon.